Hello, and welcome to this webinar on deploying JAMStack applications using Amazon S3, CloudFront, and Lambda Edge. My name is David Brown, and I'm a senior product manager on the CloudFront team here at AWS. One of the nice things about being on the CloudFront team is being able to see really broad trends in internet usage as customers use services like CloudFront. And one of the biggest trends that I've seen over the past couple years has been the rise of single page applications and statically generated sites using frameworks like Gatsby, Jekyll, and Hugo. And it's been really exciting to see the developer community around these frameworks really grow and mature. And so I'm excited to be sharing with you today some of the best practices to deploy these applications and sites to AWS using services like S3, CloudFront, and Lambda Edge. So we've got a lot of content we want to cover today, so let's jump right into it. The primary focus of this webinar is going to be around the actual deployment of applications built using JAMStack practices. We're going to focus some time on explaining what is JAMStack and some of the benefits of deploying workflows to JAMStack or using JAMStack, but we're not going to spend a lot of time on those topics. We want to spend the bulk of the time talking about how to actually deploy to S3 for hosting, and then using CloudFront and Lambda Edge for serving those applications. Now, I'm going to assume that most people are familiar with S3, at least what it is. So we're not going to spend a lot of time going through an overview of that, but we will touch on CloudFront and Lambda Edge, since those are two of the services that not everyone may be familiar with. And then once we've covered those services, we'll jump right into a demo of deploying a Gatsby application to S3, and then we'll set up CloudFront for delivery, and then finally we'll use Lambda Edge to overcome some of the challenges of using native CloudFront for these types of applications. And then finally, we'll spend some time answering your questions in a Q&A session. So let's start off with what is JAMStack. Earlier I mentioned the rise of single page apps, and which are generally built using frameworks like React or Vue. And I bring these up because these frameworks really set in motion this idea of decoupling the front end from the back end of web applications. They really helped push forward this concept of a standalone front end with its own build pipeline and deployment process. And when that idea really started taking root, we saw this whole slew of API services come about. Think of sites or services like Twilio and Discuss that made it possible to perform things like notifications and comments entirely from the front end of your application. And these approaches to building websites and applications grew. There really wasn't a good way to capture these new architectures and new deployment practices that grew out of them. And so JAMStack is really meant to be the name for that set of architectural practices and workflows for decoupled web applications. So JAMStack itself is not a framework. It is instead a set of architectural best practices. It's a way of thinking about the development and deployment of your applications that ultimately will give you better performance, scale, and if you're a developer, a really good developer experience. The JAM in JAMStack stands for JavaScript, APIs, and markup. Mostly because those are the three components that make up modern web applications, right? JavaScript runs natively in the browser, so we use JavaScript for dynamic functionality within our applications. API calls are going to be the server-side operations that we generally abstract away into reusable APIs. These could be third-party APIs like we mentioned Twilio and Discuss, or they could be custom-built APIs specifically for your application. Markup here is really going to be HTML. And HTML in JAMStack is delivered via a slightly different model than maybe most developers are used to. It's not delivered from a traditional web server that's built, that builds the page at runtime. And think, like PHP, Flask, Django, those types of frameworks. JAMStack instead takes the approach of pre-building or pre-rendering all of the HTML up front before you deploy the site, so that it can be served directly from a content delivery network or CDN. And by doing this, you no longer need your traditional web servers like Apache or Nginx. Instead, your application or your site can be stored in a simple storage solution like Amazon S3, and then served entirely from the cache of a CDN like Amazon CloudFront. So let's talk about some of the benefits of JAMStack. There are a number of them that exist, but I'm just going to highlight a few of the most prominent ones. First is that JAMStack really simplifies your systems. You've decoupled the front end from the back end, which means your developers no longer need to be an expert at both front end and back end development, right? They can focus on a single area. Your front end developers don't need to know how the back end services work. They only need to know how to interact with it through a reusable API. Generally, this means that the APIs are separated into smaller microservices that have a pretty well-defined purpose. All of this leads to just a simpler system overall. And when you pre-render your site into cacheable HTML, JavaScript, and CSS files, you take advantage of the global scale of CDNs. And CDNs give you virtually instant, unlimited scale for users around the globe. And there's no servers to scale or capacity to manage. The CDN handles all of that for you. And with that higher scale, you also get great performance. And when you're caching files on the CDN is serving the content from the closest location to the end user, which means you get really great performance. And there's no latency hit of going to a server to render that page and then serving it back to the user, right? It's all cached on the CDN. And because there's no web servers to run, you only need to pay for the static file hosting in CDN. And in the case of smaller sites, this can even be free. So for example, at AWS, you get 5 gigabytes of storage for free on S3, and on CloudFront, you get 50 gigabytes of data transfer and 2 million requests for free. And the last one I'll touch on is increased security. And so with JAMStack, you're reducing the moving parts of your application. There are no web servers running dynamic code or databases that you have to worry about patching and securing. And so when you remove those layers of your application, you're actually reducing your attack surface. Fewer parts means fewer things to attack, which means your overall security posture is improved. And not only that, but when you use a CDN like CloudFront, you get built-in security for things like DDoS protection. And if you need, for example, a firewall, the AWS Web Application Firewall is built to run right alongside CloudFront. So hopefully you're convinced the benefits are there, but how do you actually go about deploying an application using these practices? So it all starts with the development of your application. And you can develop in any framework you want, or you can build the whole thing from scratch. But the key here is your code base lives in version control, right? Such as Git. And the main benefits, of course, are you get things like change history of every file, collaboration between developers, and traceability into who made what changes and when. And any one of your developers should be able to clone the repo and get the whole entire site up and running very quickly and easily. Now, I'll mention here, there are a lot of services like AWS Amplify that will handle the build, deployment, and hosting of these types of applications automatically for you. And all you have to do in many cases is just give access to your GitHub repo, and then these services will handle the rest for you, including the building and all of that. So we're not going to use, in this case, Amplify, since we're going to be manually setting up these services, but just know that those options are available to you. So when it comes time to build the site, the whole process should be automated. And because our HTML is pre-built, content changes won't go live until you run another build and do a deployment. And so automating this process saves a lot of frustration. Automated builds remove variations and mistakes that can happen because of manual builds. Generally, your build server will build the site or application. It will do the upload of the site to the storage service and do the invalidation of the CDN cache. And then at which point your site would be live. Which then leads us to the next tenet, which is atomic deployments, right? The build process should handle the deployment step of uploading the entire site, but it should not just do the changes from the previous build. Uploading one or a few files at a time can cause this inconsistent state with your site while the deployment process completes. And so you can avoid doing this with using atomic deploys, where no change goes live until all of the files have been uploaded. And each deploy is a full snapshot of the site itself. And this helps guarantee a consistent version of the site globally. And then the final step of the atomic deployment should be to invalidate the CDN cache. Since all the markup and assets are pre-built, they can be served from a CDN. And assuming your site is using a CDN caching, which it absolutely should be, once your build is uploaded, the deployment process should then invalidate the CDN cache. Otherwise, your users will see the old cached version of the site, which we don't want. So once you've issued the invalidation, the CDN will start reaching out to the origin for the new updated content. It will then start caching that content based on the caching policy that you have set. And at this point, your new build is live. So now that we've looked at the workflow, let's spend a few minutes just talking about a couple of the services that we'll be using to actually deploy our demo site. We're going to start with the CDN, and Amazon CloudFront is Amazon's content delivery network, or CDN. And we've talked a lot about the importance of using a CDN with JAMStack applications. And CloudFront is a CDN we're going to be using in our demo today. And CDNs are great at content acceleration to improve your application's performance. And this performance comes from the fact that we're caching content from multiple locations around the world. Today, CloudFront has over 200 what we call POPs, or points of presence, around the world for caching content. And this means that we're usually just a single network hop or two away from most ISPs around the world. So CloudFront's giving your site or your application amazing performance from anywhere in the world. CloudFront is also tightly integrated with other AWS services. So for example, in our demo, we're going to be using S3 to store our pre-rendered files. And so you can easily set CloudFront to use S3 as an origin, and CloudFront will automatically set up the correct permissions so that your S3 bucket remains private, and only CloudFront has access to pull content from that bucket. And you can do all of this with just a couple of clicks in the console. The other service we're going to be using in our demo is Lambda Edge. And Lambda Edge is an extension of AWS Lambda that allows you to run serverless functions at the AWS Global Edge in response to CloudFront events. So you get all of the same benefits of Lambda's serverless compute, but now you can program CloudFront in ways that you couldn't do before, right? And so this allows you to programmatically provide a very personalized, a great experience for your customers by running code at the CloudFront edge. And so Lambda Edge can be triggered by CloudFront at 4 different event points. Viewer request is the first event point, which occurs on a request coming into CloudFront. So this happens before the CloudFront cache. And so you can manipulate the cache key, or you can rewrite URLs based on a language of a user to a different version of the site. Origin request events are triggered only on cache misses, which means the content's not found in CloudFront cache, and we need to fetch it from the origin. And so at this stage, you can either change the attribute of the request, for example, changing the URL before going to the origin, or you can even change the origin completely on the fly and go somewhere else. Origin response events are triggered once CloudFront's gotten the response back from the origin. And you have the possibility here to alter the response before CloudFront caches it. So for example, maybe you want to try a different origin if one origin responds with the 404 error. Or you can set cache control headers if the origin isn't actually setting them. And then the last event trigger is viewer response, which are triggered before the response is sent to the viewer and after the object has been served from the cache. And this is generally used to add response headers before sending the response to the client. So these would be headers like your HTTP strict transport security headers, or HSTS headers. So within a cache behavior in CloudFront, you can run 1 or up to all 4 event triggers on a single request through CloudFront. So Lambda Edge really gives you a lot of power to handle and manipulate requests in response in CloudFront. And we're going to see how we use that here in our demo. So let's talk a little bit about the demo we're actually going to be deploying. This is just a high-level overview of what we're going to be setting up. Looks pretty simple, right? But let's unpack this a bit, because I think there's a lot here. And so let's start with the private S3 bucket. So if you've read online about how to deploy either single page apps or static websites to CloudFront, you'll often see recommendations to set up the S3 bucket using a feature of S3 called static website hosting. This is an option that allows you to serve static files directly from S3. The static website hosting gives you a few nice features which are really handy for single page apps or static websites, which we're going to talk about here in just a moment. But I want to highlight some of the problems with this approach. First is that your S3 bucket must be made public in order to use static website hosting. And for a lot of organizations, public buckets are a non-starter. Second is that static website hosting does not support HTTPS. It only supports HTTP traffic, which again, for a lot of customers is a big security concern. So ideally, we want to disable static website hosting. We want to keep our bucket private so only CloudFront has access to get the content. And we want to ensure that CloudFront is only using HTTPS when talking to S3. And therefore, I think it's important to spend a few moments describing why a lot of these blog posts tell you to use static website hosting as an origin to CloudFront instead of a private bucket. Now, I briefly mentioned those couple of nice features of static website hosting. Two of the biggest features are index document and server-side redirects. And let's talk about both of those features in the context of using a private bucket with S3. So the biggest reason blogs tell you to use static website hosting is because of this index document feature. The index document allows you to specify a file name that will serve as the index document when the incoming request doesn't include a file name as part of the URI path. So for example, if you set up index.html as the index document, a user that went to www.example.com, S3 will rewrite that request to www.example.com/index.html. And the same thing would apply to subdirectories on the same domain as well. So for example, a request to www.example.com/blog would be rewritten to www.example.com/blog/index.html. If we made our bucket private and therefore turned off static website hosting, we would have lost the index document functionality. So in CloudFront, there's a feature called the default root object, which is sort of the same thing as the index document in S3. However, the default root object only applies to the root directory, not the subdirectories. So for example, if you set up index.html as the default root object in CloudFront, and a user went to www.example.com, CloudFront would rewrite that request to www.example.com/index.html on the way to S3, which is what we'd want. But if a user went to www.example.com/blog, this request is no longer on the root directory, and therefore CloudFront would not rewrite this URL and would instead serve it as is to S3. And this would, of course, result in a 404 error because there isn't a file called blog in my S3 bucket. And there's no way to fix this natively within CloudFront. So to fix this problem, we're going to use a Lambda Edge function on origin request. Now I've called this function index.docFixer. And this function will intercept requests to S3 and check that there's a file name and an extension. If there isn't a file name and extension, or if the URI just ends with a slash, then the function will append index.html to the URI before sending it to S3. And so this is going to give us the same functionality as the index document in S3. The other big reason blogs tell you to use static website hosting instead of private buckets is because of server-side redirects. With JAMStack, you're not running your own web server. And so if there are redirects that you need to make on the server side, you have to do them as part of the storage service. And S3 static website hosting gives you the ability to set redirects as part of the metadata of an object. So when you upload an object to S3, you can specify the redirect that should take place when a user requests that object. So for example, path1.html should be redirected via a 301 to path2.html on the same domain. Or you can say something like, if someone requests path3.html, they should instead be redirected to a completely different domain like www.amazon.com. If we made our bucket private and therefore turned off static website hosting, we would lose the server-side functionality, the server-side redirect functionality. The metadata for the redirect is sent to CloudFront as a response header from S3, but CloudFront will ignore the header. It doesn't know what to do with it. So if a user went to path1.html, they would still be served path1.html from S3, and path3.html would still be served path3.html from S3. The redirect simply just wouldn't happen. And that can be a big problem for a lot of sites. And again, there isn't a way to fix this problem natively in CloudFront. So going back to our architecture diagram here, we can see now there's another Lambda Edge function on origin response that I'm calling the redirect manager. This function will look at the response being sent from S3 and see if the metadata redirect is in the response. If it is, then the function will issue a redirect response from CloudFront, which will then be passed to the client. And the nice thing is this function actually sets a TTL, or time to live, for that redirect, so that the next time a user makes that same request, CloudFront will immediately serve the redirect from cache instead of going to S3. And this really is meant to just cut down on the number of times we need to run this function. So with these two Lambda Edge functions, solving the index document problem and the server-side redirect issue, we can now safely disable static website hosting and keep our bucket private. So only CloudFront will have access to the bucket, and all communication to the bucket will be over HTTPS. So let's stop here, let's jump into the demo, and let's show you how to do all of this. So I'm going to first start here in the console, and I'm going to just pop over here to S3 real quick. And this is the bucket that we're going to use. It's called JS Webinar Prod. I've already created the bucket, but you can see the bucket's empty. And if we go over here to permissions, you can see I've got to the block all public access on, and there's no bucket policy here giving anyone access to the bucket itself. So let's pop over here to Visual Studio here. And I just wanted to show you how we're actually going to deploy this app. And so this, again, is the Gatsby app that I've written. It's a very simple app, but under the package.json, there's a couple of different script options. And one of them is for deploy, which is what I'm going to use to actually deploy my site. And I'm just going to run this simple shell script called deploy.sh right here, which is this file right here. And I've just broken it out into a shell script just because it's easier to see for demo purposes. And so we're going to do essentially three things within the deployment itself. Gatsby comes with some nice build options, which I'm just going to use. Gatsby build here will just do the build itself of the entire website. And then I'm going to use the AWS CLI to do the copy of the content into S3. And so when you do the build, Gatsby is going to put all of the content into a folder called public, which you can see here is over here. And these are going to be all the files that I need to upload. And so we're going to take everything in that public folder and we're going to upload it to our S3 bucket here, which is JS Webinar Prod. And then the last thing we're going to do as part of this upload is set some cache control headers. And this is going to be metadata that gets appended onto each object. And I just want to spend a couple minutes talking to you about what we're doing here. So the first directive is public, which basically allows anyone to cache this content. Again, these are pre-rendered files, so we want to take advantage of caching. And then you'll notice there's a max age and an S max age. And the difference between the two is S max age is meant for intermediate proxies. So in our case, a CDN. And so we're telling the CDN to cache this for a really long time. This is in seconds. This is basically a year in seconds. And then max age is what the browser itself will cache. So your local browser caching. You'll notice there's a big difference between the two. And that's because on a CDN, whenever there's a change in content, we're going to do a new atomic deployment, and then we're going to invalidate the cache. So there's no reason not to tell the CDN to cache something for a really long time. But on the browser side, I don't have a way to effectively clear browser cache. So I don't want to set a really long TTL on the browser side. I want to set it for something like 300 seconds, which is about 5 minutes. And so basically the maximum amount of time a particular user will have stale content would be 5 minutes before it checked with the server to refresh the page. This is going to vary depending on your application and what your application and how frequently you're updating your application, but just know that you can specify both a browser and a CDN caching policy. And then the last thing we're going to do is issue the CloudFront invalidation to clear all of the previous site out of cache. And I'm doing the path here as /star, which means clear everything out of the CDN cache. And then I'm just providing it with the distribution ID, which is basically the name or the ID of my CDN configuration. I've already set up the CloudFront distribution just to save some time setting that up, but we'll go through and actually show you how to configure it properly. And so all you need to do is just do npm run deploy, and then it will go through this. So you can see it's running my shell script, my deploy.sh. And now we're going to go through the build process, and it'll take a couple of seconds here to finish. But my site is very small, so it doesn't take too long to build the entire thing. And then once that's done, it's going to start uploading the content, which it's doing right now. And then finally, it's going to end with an invalidation. And this is basically the output of the invalidation is just a status of in progress, which you can check against this ID to see when it's done. But if we go back into our console here, and then we refresh here, we go back into the bucket, you can see now we've got all of our content here in this bucket. So we've uploaded all the content. Now let's actually go and start to set up CloudFront. I'm going to go in here to CloudFront. And you can see I've already got the distribution here, but it's just a shell of a distribution. There's really nothing set up on it. So we're just going to go through here and edit this. And the reason why I set this up ahead of time is it creates DNS entries, and those can take a couple of minutes to propagate everywhere. So I didn't want to wait for that couple of minutes. So on the general tab here, this is where you can set your actual domain name that you want to use for your site, like www.example.com. For this demo, I'm just going to use the cloudfront.net URL that it gives me, but likely you wouldn't do that for your site. The only thing we really need to change here is the default root object, which we talked about earlier. So I'm going to set this to index.html, which again, this is going to be if I don't supply a file name and extension on the root of the domain that I'm requesting content, it's going to append index.html to that. The rest of it you can leave the same, so I'm just going to click yes, edit. And then on the origin and origin group, you can see I've already got the origin here set up, but I'm just going to clear this out here just to show you what it would look like. So when you click into this field, you can see all of the various S3 buckets that are in your account. I'm going to click on yes to JS Webinar Prod. You can give it an origin path if you want. So if your content wasn't in the root directory of your S3 bucket, you could give it an optional path. In our case, everything's in the root directory, so we don't need to do anything. Now here's where we actually give CloudFront permission to pull content from this S3 bucket, and that's under this restrict bucket access. So I'm going to click yes to this, and then I'm going to say create a new identity, and it's just going to create this name here for me, but you can change it to whatever you want. And then you click yes to update your bucket policy in S3, and then we're going to click yes. Now, if I go back over here into S3, close out of this screen here, and I go to permissions, and I go bucket policy, now you can see, whereas before I didn't have anything in this bucket policy, now I've got this entry in here which CloudFront has written, which is my origin access identity, which is basically giving CloudFront the ability to get objects out of this bucket. So CloudFront's gone ahead and set everything up permission-wise to pull content out of the S3 bucket. So back in CloudFront, if I hop over here to behaviors, CloudFront will automatically create a default web behavior for you. Let's just edit this really quickly. And it's already selecting this as our origin, since that's the only origin that we have in our account. And this is just going to redirect all requests from HTTP to HTTPS, which is a good practice to do. Because my site only allows GET requests, I'm not doing form input. No one's uploading content to my site. I'm just going to leave this as GET and head. And then under object caching, because we set that metadata in S3, we can use the origin cache headers, right? S3 is setting the caching policy for us, and we just want CloudFront to honor that. So we're just going to leave that as is. But if you didn't, and your origin was not sending cache control headers, you could change those here by doing customize. And then the last thing we want to set here is on compress objects automatically. We're going to want to set this to yes. So all of these files, HTML, JavaScript, CSS, those files can be compressed. And S3 is not going to do the compression for you. So CloudFront, before it sends the object to the user, can actually do compression of the object itself. And then it will cache both the compressed and the uncompressed version. So it's got both of them in cache. So we'll want to turn that on just to have that nice feature of automatically caching. And then we're going to use some Lambda functions in a bit, but for now, we'll just leave that blank. And so now we click yes, edit. And at this point, we should be able to actually go to our site. So I'm going to go back to the general tab. I'm just going to copy this. This is our domain name for our site here. And if we go here, you can see here's our site. It's loading now. And if I go, click across the site, everything seems to be working as expected. So I'll mention a couple of points. I'm going to open up the developer tools here. And I'm going to just go to a random page, just a gibberish page. And so you'll notice a couple of things. One, I don't get a really nice error page. And two, if you look down here, I'm actually getting a 403 response from S3. And a 403 response is a forbidden response. And the reason why that is if we go back to S3 into our bucket policy here, I've only given CloudFront access to get objects out of this bucket. There's no way for it to know or to look through the bucket to see if the file's there. If it's not, it just returns a 403. So we can actually fix this. I'm just going to copy this. I'm going to paste in a new block here. And instead of saying get object, I'm going to say list bucket. And that's going to give CloudFront the ability to look through the bucket and see if the file's there. And if it's not, it will return with a 404 instead of a 403. Now, S3, when you have a private bucket, sends 403s as a security mechanism. And generally, if I wasn't giving access just to CloudFront, I probably would keep it as a 403. But for our sake, I'm going to separate this out as 403s and 404s. So I'm going to click save here. And then I'm going to go back to my site. And I'm going to refresh. And now you can see I'm still getting this crummy looking error page, but now I'm actually getting a 404 for the page not being found. And so the advantage of having these broken out as 403s and 404s is really because I can do a couple of things. One is I could start to do authentication of my pages, right, where I have a user log in with the username and password. And if that fails, I want to be able to differentiate between an actual 403, like someone had incorrect credentials, versus a 404, which is just a page not found. Or maybe I want to add something like a web application firewall in front of it, where if I have bots or bad traffic coming in, I want to serve those 403s, and I want to be able to tell when it was the WAF that was blocking something versus someone requesting a file that just wasn't there, right? So there's real advantages to separating out 403s from 404s. So now we've got our 404 set up, but it still looks really crummy. So I'm going to go back in here to CloudFront, and there's a tab up here called Error Pages. And this allows you to set a custom error page for your sites. So I'm going to click 404 since that's the one we're looking for. You can actually cache 404s or any of these responses automatically, and I would highly encourage you to do some level of caching, but for this demo, I'm just going to disable it because we're going to be doing a couple of different things with it. Then you can give it a response page path, which in our case, the 404 page is 404.html. And then I'm still going to respond with the 404, but you could overwrite the response to be something else if you wanted. And then we'll click create here. And now if I go back to my site, it probably will take a couple of seconds here for it to propagate. I'll just keep refreshing it here a few times. There we go. So now when I go to a random page, it looks nicer. I've still got my banner up at the top and all my links, and I just get a 404 page not found. So that's a nice feature of CloudFront. Now, one other thing I'll mention is let's go to blog here. So you'll notice I go to blog, I get the page, it works just fine. But if I actually go directly to /blog, we scroll up here, you'll notice I got a 404 when I went to it directly. Whoops. Let's try that again. You'll notice I got a 404 here when I went to blog, but the page still loaded. And that's because my 404 page has the routing knowledge, the know-how to actually get me to the right page that I was really going to. So when you're loading it in the browser, it looks like it's working fine, but you're really getting a 404, which can cause problems if you're doing things like search engine optimization and you don't want crawlers to actually see that you're returning a 404. You actually want them to see an actual page and be able to, be able to log that page as part of the crawler. So we're going to want to fix this problem, right? And so the way that we fix this is again that index document problem where I'm no longer on my root domain, and so I've got to go in and use a Lambda Edge function to actually fix this. So if we go back into the console, we're actually going to hop over here to Lambda. Let me change my region here to US East 1. And so with Lambda Edge, I'll just briefly talk about some of the gotchas with Lambda. So if you click create function, if you're using Lambda Edge, you'll want to choose a new role from an AWS template. And then under this template, there's one called Lambda at Edge permissions, this one. This one will set up all the right permissions for you when you're using Lambda at Edge. And this is a slightly different role than the standard role that you can pick here, which is just create a role for basic Lambda permissions. They are different. So make sure you pick the Lambda at Edge role, not the basic Lambda role. And so I've created these two functions already. We'll just take a look at the index doc fixer function itself. And this is the actual function logic, very simple function. All we're doing is taking in the CloudFront request as it comes in, and we're pulling out the URI from that request itself. And then we're doing a check here to see if it ends with, if the URI ends with a slash. If it does, then we're going to append index.html to that. And then the other check we need to do is check to see if it includes a dot. And if it doesn't, then we want to include /index.html. So in our case, when we went to here, /blog, it doesn't end with a slash, but there's no actual file name and extension. So we want to include that into the file. And then we just simply pass the function as is to S3. And so let's quickly deploy this. So to deploy it, you just go add trigger. And then under trigger here, you pick CloudFront. And then you do deploy to Lambda at Edge. We've only got one distribution, so it's already selected it. Again, we've only got one cache behavior, which is the default star. And then this we want to run on origin request. So I'm just going to click acknowledge. And then I'm going to click deploy. And voila, our function is now deployed. So if I go back here to CloudFront, and I go to my behavior, we'll edit that. If we scroll down, we can see now we've got an origin request Lambda function, and it's our index doc fixer function. So I'm going to cancel out of here. Now, if I go to this page, again, it might take a few seconds here for it to actually load. You can see I'm still getting a 404. Still getting a 404. And there we go. Now I'm getting a 200 on this page right over here. So now, if I go to any of these pages, like for example, why JAMStack, if I go directly to that page, I now get a 200 instead of a 404 like I was getting before. And so this is fixing that index document problem that we mentioned, which is one of the main reasons why people suggest using static website hosting. All right, so the other thing that customers use S3 static website hosting for is for the server-side redirects. And so I'm actually just going to upload a file here just because I've got one here called redirect.html. And we're going to use this to actually set some metadata to do a server-side redirect. And I'll show you how that works. So here's the file that I just uploaded. I'm going to go to properties and I'm going to actually add some metadata here. And so normally you would do this as part of the upload process, but for the sake of this, I'm going to do it manually. So the first thing I want to do is just basically to disable caching of this so that CloudFront won't actually cache this file. And then we'll add, and now we're actually going to here do the metadata for the actual server-side redirect, which is called website redirect location. And in this case, I'm just going to tell it to go to Amazon.com. And we'll click save. So now if I go back here, you can see I'm basically not going to cache this file. And if anyone goes to it, they should be redirected to www.amazon.com. So if I go back in here into my website and I actually go to redirect.html, you can see I get this page that just says, if this site redirected as expected, you would not see this message. And if we actually look at the headers that are coming back from this file itself, you can see here's the file, the header from S3. So S3 is actually sending us the correct redirect header. It's just CloudFront doesn't know what to do with that header. And so it just ignores it and just serves you the page from S3 as you would expect. And so again, to fix this, because there's not a native way to do it in CloudFront, we're going to go back into Lambda and we're going to deploy that other function that we had created. So we are now going to look at here the redirect manager function. And so this function, slightly longer, but still pretty simple. Instead of getting the request, because this is going to run on origin response, we're going to look at the response, and then we're going to get the response headers. And then this is just an attribute of just pulling in the domain name of that came in on the request. And so we're really just looking for specifically for that XAMZ website redirect location header. If it exists, then we want to pull out the value of that header, which is what this line is doing. And then we want to see if the redirect itself starts with a slash, which if it does, that means it's a local or relative redirect, in which case we need to have CloudFront construct the entire URI or URL. So we need to do https:// plus the host plus whatever that path is in here. If the redirect URI does not actually start with a slash, then we assume it's the full URL, and we can just plug that right in here into our response. And so this is the response itself. So instead of serving the file, we're going to tell CloudFront to respond with the 302, and then we're going to pass in the location header here, which is going to be our redirect URI. And then the nice part about this is we're actually setting some cache control headers here so that the next time someone comes to this URI, we've got the redirect cached, so we don't actually have to go to S3 and execute this function again. We can just serve it directly from cache. And then we're just going to return the response to CloudFront, whatever it is, whether it's the redirect or just the file itself. So again, we're going to deploy this. We're going to go here to trigger. We're going to go to CloudFront, deploy to Lambda Edge. And again, same distribution, same cache behavior, only this time we're going to do it on origin response. Click acknowledge, and then we're going to deploy. And then again, if we go back into our cache behavior, we edit this, and we scroll down, you can see now we've got an origin response here. So we'll just cancel out of here. We'll go back Might take a couple of seconds here for it to, oh, it already worked. So now when we refresh this page, you can see if we scroll up here, our redirect is now getting a 302 response. It's being cached, and then we're immediately doing the redirect to S3. All right, so that's it really. Through the use of these two Lambda Edge functions and through the small tweak to the bucket policy, we've now given our our CloudFront distribution the same features as static website hosting. And so the nice thing about this setup is you really only need to do it once. And so all the future changes to this site are done using invalidation, and they're not actually changes in CDN configuration. So now if you wanted to get really ambitious, you could automate the entire setup of CloudFront and Lambda Edge using something like CloudFormation and have that entire workflow deployed automatically for you. But we're not going to cover that here in this demo. So I hope you found this helpful. We've got a few minutes left, so let's stop here and let's open it up for some Q&A.